Team Unit 5, Lesson 4. Today we're working with non-unit fractions using models, pictures, and fraction notation. Non-unit is anything that doesn't have a 1 on the top. So 2 fourths, 3 fourths, 4 fourths, 5, 6, 6, 6, anything like that. And today a non-unit fraction is with a numerator. A non-unit fraction is a number with it, dear Lord. Non-unit fraction with a numerator other than 1. A non-unit fraction is made up of copies of the unit fraction. 1/4, 1/4, 1/4 equals 3 fourths. And a fraction can be described as the remaining fraction and the fraction equal a whole. So we need kids to be able to see that. I'm going to come back to this because I got really frustrated with identifying that. And so I want to make sure that I'm practicing first before I do that. So today we have a couple clear thinking questions. Network said, how many equal parts are in the whole? How can I use a unit fraction to create non-unit fractions? And how many unit fractions make up this non-unit fraction? So we're going to see if that works out for us here and if we need to make any changes to that. So as always, annotation, big problem, knowns, unknowns, a representation, and the representation is the scholar thinking today. So if we need to model 3 fourths, because there's some cake and there's 3 fourths cake left. 8 some represent 3 fourths cake, and then the representation is actually where we're going to come in. So the first thing I do is I create my whole. I'm going to do a circle today because cakes are generally circular to me. The key scholar thinking that I want to be able to get them to be able to, I can identify and create a non-unit fraction by asking myself, key scholar thinking, how many total equal parts in my whole question mark from 3 fourths. There should be 4 because the denominator represents the total equal parts in the whole. Great, I'll represent that. You should use rectangles, and I used a circle. You should always use rectangles, as seen here. Great. How many parts are we referring to? This was 4. This is going to be 3 because 3 pieces of the cake left. So how many equal parts? How many equal parts are in the whole? What does each part represent? Each part represents 1/4, 1/4, 1/4, 1/4. What fraction represents the parts referred to? That would be 3 fourths because there's 1, 2, 3 fourths. And then 5, that's actually the interconnection. How can I use my unit fraction to create a non-unit fraction? And how many unit fractions make up this non-unit fraction? That's what they want you to prompt with. And I want you to see, this sequence is really strong if kids aren't getting it. How can we model 3 fourths? Is this the one that I just read? It was really good a second ago. We can use our blocks to make up 4 equal parts. What about the numerator 3? How is this different from a unit fraction? Unit fraction normally has 1. This has 3. Great. Yep, a non-unit fraction. So where in our model is 3 fourths? Show 3. So if this shows 3 fourths, how much is the one piece? 1/4. How do you know? Blah, blah, blah. Think about whatever we did. Blah, blah, blah. What do you notice about the relationship between 1/4 and 3 fourths? I notice that 3 fourths is made up of 3 parts, and each one is 1/4. Yes, a non-unit fraction is made up of unit fractions, is what you want to get to, and then you do that big reveal right here. So don't show them that at first. And then, so your key idea right now is I can create and represent non-unit fractions by thinking how many unit fractions equal the non-unit fraction. Makes sense? Okay, so then here's the deal. You also need kids to understand that this was 3/4 left and that this is 1/4 eaten, because you want them to understand that whole, which is 4/4, is made up of 3/4 and 1/4. Got it? Down here, same thing. Build a shape. What fraction can you build a shape below with your pattern blocks or tiles? What fraction can you write to represent the shaded part? I can't see the shaded part here, so I'm worried that your kids won't be able to, so please be cognizant of that. Let's say, I think it's supposed to be 3. So ask myself first, how many total equal parts am I whole? 8. How many parts are you referring to? 3. What does each part represent? 1/8, 1/8, 1/8. What fraction represents the parts we're referring to? 3/8. What part is left over? How many parts do we have in all? 8. How many parts are we referring to? 5, 5/8.